All right, in this lesson, let's start our model building process in Keras. Models in Keras are defined as a sequence of layers. We create a sequential model and add layers one at a time until we're happy with the network topology. So down here we can see on our first line, this is where we define our Keras model. Model equals sequential. All right, so what does that mean? So let's come up here and draw this. Think of this as a box. This is sequential, SEQ, right? And inside here are our layers. There's the first layer. There's the second. This should probably be called lasagna instead of Keras, right? So each of these is simply a layer of a neural network. All right, so the next thing we need to get right, or the next thing we need to think about, is this, input dim. So what that means is input dimensions. So in our data set, we need to tell it how many columns we have. Right? Those are the dimensions. I shouldn't say columns, I should say attributes, right? Each one is an attribute. I have to get used to the vernacular of machine learning. All right, so 11, because we have 11, I'm going to do it again. We have 11, I'm calling them columns. So we have 11 columns in our data set. And that's what we mean by dimension. All right, so we have the input dimension. That's what that is. All right, now we have to define our fully connected layers. And we define our fully connected layers with the dense class right here. So you're thinking, okay, well, that's great. What's a fully connected layer? Let's come up here and draw that. Fully connected layer, here we go. Here are our neurons, and it just means, there we go, there we go, there we go, there we go. All neurons in this feed-forward model are connected to one another, right? There are no gaps. That's simply what that means. We can specify the number of neurons in the layer in the first argument. So here, in our first input layer, we have how many? 11 neurons. Here we have 8, another 8, and the output is 1. Why? Because in the output, we've got a 1 under 0, right? That's it. It can only be one of those two. It's a binary classification problem. The initialization method is a little more complicated. In this case, we initialize the network weights to a small random number generated from a uniform distribution. That's why we call it uniform. In the case, it'll be between 0 and for now, that's great because that is the default uniform weight in Keras. Lastly, we have this thing called an activation function. And here we're going to use the ReLU activation function, which is short for rectifier activation function. We're going to do that on the first 3 layers. You can see we've got it there, we've got it there, and we have it there. Here we have a different function. It's called a sigmoid function. And we use the sigmoid function to ensure that our output is a 0 or a 1. Activation functions are really beyond the scope of this course. You'll find ReLU being used often except for the output. So activation functions are strange. Activation functions just simply mean within the network model, are we going to fire? Right? So here we've got these things. We've got this and this, right? We'll call this the act for the activation function. So he sees the data here, right? And either there or either there. And he says, do I fire or do I not fire? All right. Now, obviously, it's a little more complicated than that, but that's kind of the gist of it. And that's it. We've built a how many layer model? You can see here. 1, 2, 3, 4, a 4-layer model. Now up here I have a question. How many layers are hidden layers in our model? All right, so you tell me. Well, the input layer, right, this first one, is not hidden because it's an input. The output layer is not hidden because it's an output layer. So we really only have 2. All right, so we have 2 hidden layers. That's our answer. Another good question might be, if we look at this, is this considered technically a deep learning model? Well, yeah, because it has 2, right, hidden layers. Here are our inputs, here are our hidden layers, and here is our output. All right. All that, I'm not going to go through and draw all that, but you get the idea. All right. So yeah, this is a deep learning model.